Calculus is the branch in mathematics that deals with finding different properties of integrals and derivatives of functions. Okay, let me circle up this of functions. Okay, so I'm going to be talking now about differential calculus and how to find derivatives of a function. Okay, so that's the differential calculus. Differential calculus deals with the rates, means right, the rate of change of one quantity in respect to another quantity, right? So we say that a function is defined as a relation between a set of inputs having one output each. It's not very, very clear, but I think I'll make a video to explain what the function is. But let me just give you the idea of what it is. The one particular very popular kind of function is one called algebraic function. We take, for example, a function like this: f of x equals to 10x squared. All right, so this is a function. This is an algebraic function where f represents the function and x here is like the dependent variable. So if I ask you to find something like, let's say, f of 1, we simply put in the value for 1 here. So we see f of 1 is equals to 10, since x is equals to 1, so y raised by 2, that will give me 10 times 1, that will give me what? 10. So f of 1 is equals to what? Is equals to 10. And this here is the output. This here is the output of the function. While x as 1 is the input. So the function is defined as a relation between a set of inputs having one output each. So you can see this input give us only one output. So that's what a function is. Well, I'll make a video to you explain functions. In this video, I have to talk about calculations, how we can find the derivative of a function. I think we have one kind of function called algebraic function. Whenever it's something like this, you see x something was by x or whatever. So whenever you see something like this, it is called an algebraic function. We have other kinds of functions. I've read a lot of them, but I think the most popular ones are algebraic function, logarithmic function, this is natural logarithm, exponential function, this is e raised by x, and tree function, this is sine x. So there are very many functions, but we'll talk about those ones in this video. So if you're given a function f of x equals to 10x raised by 2, I asked to find. Now, what does this mean? This means, this statement here, this over here, it means the derivative of x. So we're asked to differentiate. To differentiate means to find a derivative of what? Of x. Now, how do you do that? Now, before we set the question, let us set up some basic rules. Some basic rules of differentiation. Okay, I can write this as equals dy dx. Is the same thing, okay? So when we see f prime of x like this, and you see dy dx, they both mean the derivative of x. That means differentiate what? Differentiate x. In this case, this is why it is f prime of x, and write dy dx because the function here is f and not y. If it was something like this, y equals to 10x squared. In this case now, if we ask find the derivative of x, it means that you're looking for what? Dy dx. So I'm differentiating y in respect to what? X, where y is the dependent variable and x is the independent variable. So when we differentiate a dependent variable in respect to an independent variable, so we're differentiating y in respect to what? X, and then differentiating the function f in respect to x. Okay, now if we have something like function f is equals to x raised by n, the derivative of the function in respect to x will be equals to nx raised by n minus 1. Where this n, let's imagine this n comes in the back like this, multiplying the entire expression, and we have n x raised by n, move on from this n becomes n minus 1. Also, if you have a function f with respect to x to be equals to leaving x, derivative of x will be equals to 1 over x. These are rules that we should just have to know. We're giving f as a function in respect to x to be equals to sine x, then the derivative of x will be equals to cos x. We're given a function x because x, derivative of the function in respect to x will be equals to minus sine x. Also, we're given a function f to be equals to tan x, then derivative of the function will be equals to sec square x. We're given a function to be cot x, then the derivative of the function will be equals to minus cosec square x. We're given a function to be cosec x, the derivative of the function will be minus cosec x cot x. We're given a function to be sec x, the derivative of the function will be sec x and x. So our advice to take a snapshot of this. There are more, but these are the basic ones we will making this off. Okay, let me add one more. I give you a function to be e raised by x. Then the derivative of the function is f squared x e raised by. I should take a snapshot of this. We're going to be using these two. We're going to be applying this in 7 questions on differential calculus. And don't forget that this f times x is same as saying dy dx. So this is same as saying dy dx. So going back to the question, the initial question was to solve. We're told that f as a function of x is tan x raised by 2. Find the derivative of x. Again, this looks like the first case scenario. Okay, where the power comes to the back and multiplies the entire expression. And let's do the same thing here. So the power is 2. Okay, so it comes this way in a different color. So the power is 2. So to multiply the entire expression, it becomes what? 20 x raised by 2 minus 1. That's give me 20 x raised by 1. That will give me 20x. So let's find the derivative of these functions. Okay, then I wrote this in form of y equals to 5x squared plus 6x, where y is the dependent variable and x is the independent variable. So hence, we're looking for dy dx, because we'll be differentiating y, that is the dependent variable in respect to x, the independent variable. So let's take a look at the first question. This one says y is equals to 5x squared plus 6x. Okay, so divide dx means that I'm differentiating each of them, right? So I'm differentiating 5x squared with respect to x, and I'm differentiating 6x with respect to what x. And let's do that. You know what to do, as I said, the first scenario is when the power comes to the back, isn't it? This is a algebraic function. I think this should be the easiest. You two multiply everything, becomes what? Becomes 10 x raised by 2 minus 1 plus x still has the power of 1. So if 1 multiplies everything, it becomes what? 6x raised by 1, then move 1 from that. So I'm going to have divide dx will be equals to 10x raised by 2 minus 1 is 1, x raised by 1 plus 6x raised by what? 0. You know that x raised by 0 is 1, so this will give me 10x plus 6. So the other question, this is y is equals to 3x raised by 3 plus 10x squared plus 6x minus 5. Again, we're asked to find dy dx. So So the y dx means that we're differentiating 3x raised power 3 in respect to x, and I'm differentiating 10x squared in respect to x. We're also differentiating 6x, in respect to x, and lastly, we're differentiating 5 in respect to x. So the y dx will be equals to 3 multiplied everything, right? Now we 9x raised power 3 minus 1 plus 2 multiplied everything. That will be 20x raised power 2 minus 1 plus, what's the power? The power is 1. 1 multiply everything to give me what? 6x raised power 1 minus 1. And in this case, there's no variable here. There is no independent variable. Let me bring this out. If I have 5 can be written as 5x raised power 0, right? But raised power 0 is still 1, so it's still giving 5. So then for the principle here, so 0 multiply everything, right? So if 0 multiply everything, what do you have? 0. So differentiation in constant, they give you what? They give you 0. So the y dx will be equals to 9x raised power 3 minus 1, 3, plus 20x raised power 2 minus 1, 1, plus 6x raised power 1 minus 1, 0 minus 0. I need this one out of the equation. This will give me 9x squared plus 20x plus 6.